Hi, my name is Christine G, and I am going to be going over a little bit about the z-scores and z-test statistics. First of all, I just wanted to, and I have in my videos on Chapter 3 and Chapter 4 overviews, I have these examples in there that I recommend, looking at, and this is just kind of putting them together. To explain further the z-scores and z-test statistics. So here I have in chapter 3, and this one is on page 71. I recommend reviewing that in the book. And then um, we have um, where we're obtaining the z-score. And I'll go over an example, but I just wanted to show side by side. So here you have the z-score equals, and then x is like the data point. And it's just one particular value. Um, so it's not like it's a mean where it's an average. And then you're subtracting mu, which is the population mean, and then you're dividing the quantity of that by the population standard deviation. So here you can see for the formula for the z-test statistic, it's a bit different. And this is done when you're doing a hypothesis test. So different formula for hypothesis test. Here we're looking for a percentage or some particular value. Here we're doing a test on this one. So what we want to do, and let me highlight. So, so what we want to do here, we have X bar, which is actually the sample mean. So that is many data points and the average of them. So um, then we subtract the population mean, and then we divide that all by the population standard deviation, and divide that by the square root of the sample size, which is n. So different formula, different thing that we're looking for. We're in, using this z-test statistic to interpret the hypothesis test to say whether we reject or don't reject the null hypothesis. Here we're getting a data point or looking for a percent or something like that. So two different things. Okay, so let's go ahead and take a look at the problem I did for the overview for chapter 3, which I think would be helpful. So here we have average daily calorie intake for boys U17 soccer players on the Rancho Santa Fe attack was 3,000 calories with a standard deviation of 400 calories. What is the z-score for the players who are eating calories in the 91.15th percentile rank? Okay, so what I always recommend doing, because I think a lot of students are visual, is to draw your normal. And in the middle, we know that that is always going to be the mean, which is 3,000 calories. And then we know each standard deviation is 400 calories. So if we go out one standard deviation, that would be 3,400 calories. We go out two standard deviations, 3,800 calories, and so on. And then if we went to the left, this would be 2,600 calories, and then this would be 2,200 calories. Then if we standardize the normal distribution, set that up, in the middle we have 0. The where the mean is 0 deviations away from the mean because it's right there. So we know that 50% of the data is to the left of the actual mean. 50% is over on this side, and then to the right is also 50. Now, we only want to go to the 91.15th percentile rank. So I can subtract my 50% from 91.15. And when I do that, I come up with 41.15%. And now I have the ability, I don't know what my score is, but I can certainly look it up in the Appendix B in your ebook. So all I need to do is pull that up. Here we have it. And what we're looking at is we are looking for, okay, so I look in the chart at 41.15. And that's right here. Okay, now. So, okay, so I put it like this. Goes here, and then this is 50% of the data, and then this is the score. I don't know what it is, but I know that it's 41.15. And this table tells us the percent of the total area of the normal curve between a z-score and the mean. So between here and here, the percent of the data, 1.15%. So now I'll be able to look up on this chart. So 41.15% is right here. So now I can get my z-score. So out here, this way, I get 1.3, and then if I go up, I know 5. So 1.3 plus 0.05, 1.35, and that is my z-score right here at 41.15% or 91.15. I now put that over here, 1.5. And then there are a couple of ways to do this. On my video, I showed a different way. I used the formula. Now, on this one, I'm going to do it differently. You can watch my video and choose my video on Chapter 3 overview and do it that way, or you may choose to do it this way. Either way is fine as long as you know how to do this. So here, I know 1.35 standard deviations from the mean is between 1 and 2 standard deviations from the mean. And then I also know that it would be between 34 and 3,800 because I went out 2 standard deviations. So it's going to be in between there someplace, closer to 1 standard deviation since it's just 1.35, so closer to the 3,400. Now, when I was calculating 1 standard deviation away, I was just adding 400 calories. But now it's not 1 standard deviation, but it's 1.35 standard deviations. So I just take that number and multiply it by 400 and add to it the original mean. And then I get my calculator out, and then I say 400 times 1.35, and I get 540. 540 plus 3,000 is 3,540. So 3,540 calories is what the soccer players in the 91.15th percentile rank are eating. That would be right around here, the 35. So all we did was find the particular data point, which was this, and then we also found the z-score for a specific percentile rank. So if a problem's talking about percentile rank or a particular data point, you are going to, and this one would have asked, what are the players eating in the 91, or how many calories are they eating in the 91.15 percentile rank, and that would have been this. So anything to do with percentile rank, I would say you're going to be looking at this kind of problem with the formula with the data point instead of the sample. Okay, now let's look at the hypothesis testing. So here we have this situation with a null and alternative hypothesis. And I go over this problem in the Chapter 4 overview. Also in the book on page 86, there is a hypothesis past statistic problem. So good to check that out. So page 86. Now on this one, so here we have this information, sample size, population standard deviation, sample mean, and we have this formula. And we were also given in a prior slide that our alpha value is 0.05. And that was picked, our significance level was picked ahead of time. So here we know that we have the 0.05. It's right here, point. And 0.05 is the same as 5%. So I'm just going to write it as 5%. And if this is 5%, well, then we know that this is 45%. Why do we know that? Because we know that each side of the standard normal curves adds up to 50%, and the total would add up to 100%. That is good to know. Now, we can get right here what our z-score would be for this significance level. So we can just look up in our z-score table, 45%. Okay, so let me pull that up and erase some of this stuff up here. And earlier we looked up 41.15%. Now we're going to look up 5%. So here it's kind of in between, it's close in between these two numbers. So I'm just going to pick this one and 45.05. And they're not going to do something on your exam where you're going to get it wrong if things in the middle like this. So either one would work. So this is 1.605, so plus 0.05, so that would be 1.5. So here we have, this number is 1.65. Now we are going to calculate this. And here we're given that the sample size, and I calculate our z-test statistic, and sample size is 36, so that is going to be the square root of 36. And then sigma, which is the population standard deviation, is 12.2. And then the sample mean is 70. And then we know that the actual population mean is 67. So now we are set, and I get to work on this. So take it one step at a time. 70 minus 67 is 3. And then this is 12.2 divided by 6. I just took the square root of 36. Then the next thing I'm going to do is I'm going to say 12.2 divided by 6, 12.2 divided by 6. And then I'm coming up with like this 0.033 repeating. And I'm going to take the 3 and divide it by 2.033. And I'm coming up with around 1.47. So here, my test statistic coming in someplace around here, 1.475 when I round it. So that is not in the rejection region. So I use this z-test to find out where I am for this hypothesis test, and I am not in the rejection region. The rejection region is right at 1.65 in the tail. And so I am too close to the mean, which is in the middle. So I'm not in the rejection region, so I cannot reject the null hypothesis the way that this is set up. Hope this makes sense, and hope it was helpful for you. Thanks very much for watching. Have a great day. Bye.